Coming to the filter structures, filter structures are of two types, one for IIR and another one for FIR filter. So in designing the IIR system, we will be using either direct forum 1 and direct forum 2. The second technique called cascading forum and third technique called parallel forum. And when we come to FIR filter, we have direct forum again and linear phase realization, cascade forum and lattice structure. When we compare with the IIR and FIR, only linear phases makes a little difference and lattice structure. Rest of the two, that is direct forum and cascade, and here also direct forum and cascade, the technique remains same in order to realize the filter structures. Now, to move with the filter structures, first I should know how the filter is going to be represented. So we take the, in order to represent the filter, we always take a linear time invariant system. So and its equation, generally if you observe, it is how the difference equation is going to be written, right? So a of k with the output, b of k with input. So it is something like ak y of n minus 1 plus the next sample y of n minus 2, and it continues, is equal to bk with x of n minus 1. So this is b1 coefficient, b2 coefficient with x of n minus 2, and it continues. And looking at this, I can always write this as output by input, right? Output by input. What is this is equal to? This is equal to nothing but impulse function, right? So if I take the transform of this is time domain approach, and if I go for the frequency domain, so this will be y of z by x of z, that is equal to h of z, right? So any difference equation in frequency domain can be represented in this form. And if you observe the y of z by x of z, which is nothing but zeros to poles. Now when I say that zeros to poles, this is nothing but a digital IIR filter. And if there is no poles, and if there is consisting of only h of z is consisting of only the the input or zeros, then this is nothing but a FIR filter, a digital FIR filter. So this is where we call about x of n is nothing but an input signal and y of n is nothing but an output signal. Now to design this, we are trying to design h of z in form of structure. When I say that structure, it is nothing but how do we implement in hardware. So that's where we will use this transfer function, where which consisting of zeros to poles. Okay, we make use of these to realize my hardware. Okay, so this is where the fundamental aim of representing the filter in form of structure, it is nothing but through the implementation through the hardware configuration or through the software program. So ultimately, some of the rearrangements are required, that I will tell you that how rearrangement are going to be done, so that I am going to get a reduction in my computational complexity, that we will see in direct forum 1. And when we move to direct forum 2, we can see this, the computational complexity is going to be reduced. So why complexity has to be reduced? One is the main important point is this. I need to save my hardware, which in turn I am trying to save my chip area, VLSI chip area. When I try to reduce my hardware, obviously I am trying to increase my speed. So if there are less connection in my hardware, so obviously my area is less. As the area is less, the computation time obviously decreases. And another very important, oh, I'm saving my memory. When I say that memory, it is nothing but number of flip-flops that I'm trying to reduce. So this is a general structure for a filter. I take y of n at output and all other as considering as an input across here. Now my output IIR filter. So this is very clearly stating that IIR filter. What is the IIR filter? So the output of IIR filter depending upon a present input, right? The output of FIR filter is depending upon my present input, that is x of k, as well as past inputs as x of n minus k, followed by, it is also depending upon y of n minus k. What is this output? What type of output? Past output. This is one of the major difference between FIR filter and IIR filter. When I move to IIR filter, look at this equation. This is how we try to represent my IIR equation, where which do not contains this y of n minus k. Obviously, it depends on only the present input and past inputs, but not on past outputs. So this is one of the very important, very important, the difference between IIR filter and FIR filter. So that's where we call this as, since it is depending upon the past output also, hence it is also called as recursive filter. So FIR filter is also called as, IIR filter is also called as recursive filter. So another very important concept with respect to IIR filter. The first difference between IIR and FIR is the impulses are infinite in IIR, impulses are finite in FIR. In IIR filter, the output depends upon the present input, past input and past output as well. Whereas in case of FIR, the output depends upon only the present input and the past inputs, but not on the past outputs. Past inputs, but not on the past outputs. Many times we will also ask you either in lab or even in theory the difference between IIR filter and FIR filter, probably for some 5 mark as such. Okay, so you make use of these equations. And one very important point: FIR filter consisting of only zeros. It does not consist of poles. One more important point. Whereas IIR filter consisting of both poles and zeros. So these are points that you can easily differentiate with using these equations. You can easily understand the differences. Now directly we'll go for the direct form one structure for IIR filter here. So consider this, let h of z. We have a h of z which will be in terms of numerator and denominator. What we do is we try to split into two transfer functions, one considering it as a h1 of z and h2z. So this is probably the numerator. I try to realize this separately and I try to realize this separately. Now this is how we try to realize the equations. So to be much more clear, I have a h of z which is nothing but output y of z divided by x of z. So if I want to represent this, so I will be representing this in this format, right? So input x of z, output y of z. Now what we do is I split this h1 of h of z into h1 of z and h2 of z, and this is y of z, and this is input x of z. So the output of h1 of z will be the input to the h2 of z, and finally output. Now this helps me for realization of the FIR filters. IIR filter. So where in case like taking only the zeros and taking only the poles, then implement them in a same order. Directly we'll go to the example here, and so that you can understand much clearly. Okay, so uh, try to take this problem. So obtain or consider direct form, consider the filter and obtain, I should cross it out, obtain the direct form 1 and direct form 2 structure for the FIR filters given a system transfer function h of z is equal to 1 plus 0.4 z inverse divided by 1 minus 0.5 z inverse plus 0.06 z to the power of minus 2. Can you tell me how to solve this? Because we already solved this type of example in signals and systems.